the second kind of section, or second part of section 4.1 of chapter 4 is the inverse function. So by definition, the inverse function, how do you determine if two functions are inverse of them, is you take one function, g of x, and you plug it inside the other function, and then go ahead and simplify and see if you get x. Okay, if that's true, then you take the other function and you're going to plug in f inside of g and see if you get x. And if you do get x on both of those, that means that those two functions are inverse of one another. So that's how you tell if they are inverses of one another. To be inverse functions, so technically it could be inverse functions. One of these functions would have to be a one-to-one function. So f would have to be a one-to-one function, and then to do that, so that's why a lot of your problems say if you have a one-to-one function, what is the inverse? You could still find the inverse. I guess you can call it the inverse equation, but technically to be inverse function, one of the f has to be a one-to-one function, because if f is not a one-to-one function, that means that g would not be a function to begin with, right? So that's why this is a linear equation. So even though you can find, like for x squared is not a one-to-one function, so but you can still find the inverse of that quadratic. They're just not technically would be that inverse. Say if f of x is just x squared, that means g of x would equal square root of x, right? And this is not a function. So that's a kind of prime example, right? This is not one-to-one, so that means its inverse is not a function. But you can still find the inverse, because these still are inverse of one another. This is just not an inverse. They're not technically inverse functions, but whatever. Okay, so let's go ahead and find and see if these two functions, f of x and g of x, are inverse functions. We'll take g, which is 1/8 x minus 5/8, and that is going to be our x. So that's our x of the f equation. So this is the x. This whole thing is this little x. So that means there's an 8 on the outside, and there's a plus 5 on the right side. And now I simplify this. Distribute the 8, so I get 8 times 1/8 x is just x. 8 times negative 5/8 is a negative 5, and then add 5, and we get x. So we got this side, and we did get x. Now we plug f, which is 8x plus 5, in for this little x right here. So that means on the outside of it to the left is a 1/8. Oops, 1/8. And then on the right side is a minus 5/8. Distribute the 1/8. 1/8 times 8x is 8x, and 1 times 5, or 1/8 times 5 is 5/8, and then minus 5/8 gets you x. So they both get you x, and f is a one-to-one function, so these are called technically, these two are inverses of each other, but they are inverse functions. So they are inverse of each other, and they're inverse functions. So that's why it says if the function is one-to-one, find its inverse. So we look at this, we're looking at points, right? 1, 2, negative 2 goes to 1, negative 1 goes to 0, 0 goes to 1. So every x so far has gone to 1y. 1 to 2, and 2 to 2. So our x's are good. Now let's look at the y's. Does every y go to 1x? 1 goes to negative 2, 0 to 1, 1 to 0. Oh, there's a repeat right here. So 1 goes to negative 2 and 1 goes to 0, as well as here 2 goes to 1 and 2 goes to 2. So this is not one-to-one. So you can just put not one-to-one. You can still find its inverse. The inverse is just not a function, all right, because this is not a one-to-one function. All you have to do is just switch your x's and y's. When we look at the second one here, it is one-to-one because all the x's are different and all the y's are different. So it is one-to-one. So all we have to do is just switch our x's and y's, because that's basically kind of what you're doing on finding the inverse. All right, we talked about this in class. So there's our set there. So this is G inverse, right? So that's G inverse. That -1 is not an exponent. It reads G of -1 is inverse of G, or G inverse. That's how you read that. So it reads inverse of G, or G inverse, or G inverse. So for a quick example, if we had these two equations, which we do, right? We have f 8x plus 5, and we have g of x equals 1/8 minus 5/8. That's a beautiful looking g. So when I plug a number in here for 2, what this means is, because these are inverses, when I plug in a number like 10, which I did in class, I get 85, right? And over here, because these are inverses, the x and y switch, right? So the x for this problem would be 85, and the y, I'd get out a y of 10. So I'd have a point 8510. This point would be 1085. Because what happens is the x's and y's basically switch. Right? If you were to graph them, they would kind of look like something like this. It's a little bit off. And then let's say that that's the f of x. And this is kind of the g of x. That's what their graphs would look like. And if I fold this, where would I have to fold this in order for these two lines to land on each other? Well, it turns out that fold is actually about the equation y equals x. Because my x becomes my y, and my y becomes my x in the two equations. So y is equal to x. Those are inverse functions. And it turns out all inverse functions you can fold and land on top of each other. Even just if they're not one-to-one functions, I can still fold them on this line y equals x. Like quadratics, right? Quadratics. Here's a quadratic. If I fold that over, it would look something like this. So it looks something like that. So you can find the inverse of any equation. So here's a couple examples. We'll let this one, the second one here, be g of x. And we're going to use the definition. So we've done this in class, but here we go again, right? So I'm going to take this, plug it in for this x, and then go backwards and plug this one in for this x. So the cube root of x cubed minus 1 plus x, and this one would be the cube x plus 1 cubed minus 1. So here you go. I can take down these bars because I'm not multiplying or dividing or anything in there, or squaring. So minus 1 plus 1 is 0, so we get x cubed. Cube rooted is x. Here a cube root and a cubed are going to cancel, so I get x plus 1, then I subtract 1 and I get x. So by definition, these are inverse functions, or are inverses, right? So this just says inverses, which they both are, because cubed and cube root, most all of them are one-to-one. Or maybe not most all of them. These ones are. Okay, how about this one? So again, it says for each function defined as one-to-one. So it has to be one-to-one, and then you can write your equation, right? So we can see right off the bat what type of equation is this, or what type of function is that. It's not one-to-one, right? So therefore, I wouldn't have to do it. By the directions, I wouldn't have to do it. And what this part says right here, it just says, you know, write as in terms of your inverse, right? Because this means the inverse of x, or the inverse of f, sorry. So here are the steps. So step 1 is to go ahead. I mean, you can kind of rearrange these however you want to. You're just doing the reverse operation. That's what inverses are, doing the reverse, going backwards, right? So here we take. Here we want to take and just switch f of x to y. I might be getting ahead of myself here, but that's okay. I actually am kind of getting ahead of myself. So I'll come back to this. I'll do this in the next video. So let me just put up your homework or problems for this section, and then when we'll do these, then I'll come back to that. Sorry. Okay, so just these 37, 41, 51, and 53. So those follow those two examples, and like I said, then I'll come back on the next video and do the rest of it. Okay, so here you're proving by definition of inverse, are these inverse of another? So I'm taking this one. I'm going to plug it in for this x, so 2 times my x is 1/2 minus 2, 1/2 x minus 2, and then plus 4. And this one, we're taking this one and plugging in for that x, so 1/2 my x, which is 2x plus 4, and then minus 2. Okay, so here distribute the 2 to both of them, so we get 2 times 1/2, which is x, 2 times 1/2 of x is just x, 2 times -2 is -4, -4 plus 4 is x, right? So that's fine, it comes out to x. This one, distribute 1/2, 1/2 times 2x is x, 1/2 times 4 is 2, and then subtract 2 and we get x. So yes, that is correct. Okay, so we'll step back to number 37, right? So we have these list of x's, 3, 2, 5, 1, 4, and then another one. So we have 2 different functions, so we're telling if both of these, decide whether these functions are inverses or not, right? So here's our x's, and here's our y's for one of them. And then I think I might have misled a couple people. I thought it was just asking, are these functions or not, or are they 1-to-1 or not? So sorry about that. So it's asking, are these functions inverses, right? So it's not even saying, are they inverse functions? Are they just inverses? So they don't even have to be 1-to-1, but I do believe that they are. So here's 2 different functions, and we're going to see, are these functions the reverse of one another? Basically, if they are, that means all these x's will become the y values, and all these y values will become my x's. And I can kind of see that, right? -4, -4, -6, -6. Let's see, 8 and 8. 9, I'm just reading from the book here, and 3. So yep, all my y's right here of f of x became my x's for my g function, and now all are my x's from my f equation, all are my x's, my y values for my g. And let's write these down. 3, is that the same? Yep. 2, yep. 5, yes. 1 and 4, yep. So they are. So yes, these are inverses of each other. So they are inverse of each other, and this f is 1-to-1, so they are actually inverse functions as well as inverses. Okay, so now we can do the other. So sometimes it is good to listen to directions, right, and pay attention. That's towards me, not towards you. If the function is 1-to-1, so I need to prove that it's 1-to-1 and then find the inverse. Okay, so let's look at this set of ordered pairs, -3, 6. So x goes to y goes to 1x. Here 1x goes to 1y, no repeats, right? No repeats in my x's, no repeats in my y's. So yes, that's a 5, a beautiful looking 5. So yep, there's no x's repeats, no y's repeats, so yes, it's 1-to-1. Now what's its inverse? Well, just flip the x's and y's. 1, 2, and 8, 5. There we go. So there is the inverse set, and they're not labeled, so there you go. There's the inverse. And now the other one. Okay, so 53, same kind of thing. Are they inverses? We have an x1, an x1, 2. So I'm just labeling my x's for now. 2, make sure I don't have any repeat x's. And then 5. So no x's repeat. Getting close there. Now let's see if we have any repeat in the y's. -3, so we're good there. -7, we're good there. -3, oh, there's 2 -3's right here. So this is not 1-to-1, so just put not hot heat hit, not 1-to-1. So not 1-to-1, I don't even need to finish at -5, yeah. So because this y repeats itself, it's not 1-to-1, so I don't need to find its inverse. You can find its inverse, right, just by switching the x's and y's, and you still can find the inverse. Okay, so that's it for this section. I'll do another video, actually how to just take one equation and find the inverse.